Okay, this is the key to exercise set 3.1. Question 1, we are evaluating definite integrals. Remember, definite integrals will have bounds between them. For example, here is 0 and 3. So the graph is here to help you visualize what's going on. For the first one, let's ignore that negative sign for now and just deal with the x. So if I were to graph this, I'm going to graph x just like this, like this. Those lines are a little faint on the y-axis, but it's something resembling this. And from 0 to 3 would look something like this. From 0 would be my lower bound, and then 1 to this would be the region I want. And this is a height of 3 and a width of 3, and it's a triangle. So the area of that triangle is 3 times 3 over 2, base times height over 2, which is 4.5. Now with that negative out in front, that's going to become negative 4.5. Okay, we are essentially proving the integral rules here. So for B, really this negative sign can come out to the front. That's one of our rules, the constant rule. But for the sake of the proof, I will go ahead and graph the negative x to show you why they're the same. So again, it's going to look something like this, and then it's going to be this region here. Okay, and then this is identical triangle to this one. So it's going to be again 3 times 3 over 2, which is 4.5. Since it's negative right below the x-axis, this is negative 4.5. So for the same reason, this is negative 4.5. And that can be proven by drawing it or through that rule that we know. Okay, here we go. Next one looks similar, but you got to be careful when reading the integrals. Remember, we want to go from, the way that we see is go from, this is lower bound to upper bound. So we should be going from low to high, right? Now this 3 is higher than the 0, so I want to flip them. So I'm going to change them to 0 to 3 x dx. And I can do this if when I flip the values, I turn it negative. And this, if you notice, is the same as a, so this is going to be negative 4.5. Okay. This one's similar. It's going to convert. We're going to flip them and convert. Remember, you're going to change the sign. So now it's negative, we're going to change it positive, right? So it's going to just be regular integral from 0 to 3 negative x dx. The inside stays the same. And we already found this one too, up here. So they're all negative 4.5. Okay. So for 1, they should all be negative 4.5. 2. Given that integral negative 1 to 8 f of x dx is 7, and integral 5 to 8 f of x dx is negative 2, and integral negative 1 g of x dx is 21, find the following. So our first one here is 8 to 5. Now, okay, that doesn't really help me here. Oh, this does look very similar. This is 5 to 8, but I want 8 to 5. So remember to convert, if I want to convert this, I can to e to 5 as long as I make it negative. So now I can write this as negative integral 8 to 5 f of x dx equals, so if I'm making this negative, this also, the value needs to also become negative. So it's going to become 2. Therefore, this is going to stay as a negative 2. We're just rewriting the way that this is written. To convert this negative to positive, then this will just become positive 2, right? If negative integral 8 to 5. So these two are equivalent statements. These two are equivalent. 5 to 8 is the equivalent of negative 8 to 5. So the integral stays the same. Okay, you're not going to change that positive. However, over here, I want just regular 8 to 5. I don't want negative 8 to 5. So if negative 8 to 5 is negative 2, then regular 8 to 5 must be 2. Okay. Next one. Negative 1 to 5 f of x dx. I don't have that exact integral up here, but I do have two that are similar. So when you see this f of x in here, you know you're going to be dealing with the f of x's. I don't care about the g of x. It's only the f of x's that I'm worried about. And I see here, well, I've got the negative 1 here, and I have the 5 here. So what I can actually do is I can combine these two to give me this region. Something helpful to do sometimes is just to do a little sketch of what this kind of looks like. So imagine like you got some like f of x like this, and we're going from negative 1 right here to 8 right here. So I know this region here is 7. And I know this whole region. And I know that the region from 5 to 8, this is 5, this is 8, this is negative 1. So the whole thing is 7. But this specific region here, so I'm going to kind of draw 2 arrows there. Just this region here is negative 2. This is not to scale. This is just like a visual to show what we're doing. So if this whole thing, 7, and this region is negative 2, then what's this region, right? So what we can do is basically what we're doing is this equation. We're doing the big integral, negative 1 to 8, f of x dx, minus a little integral, 5 to 8, f of x dx, to get, so basically doing this big integral minus this little integral to get this right here. Okay, so when I take the big integral, which is 7, and subtract the little integral, which is negative 2, I get 9. So this region must be 9. So one more time. This 9 plus the negative 2 gets me 7. So I know that 9 is correct. Okay. All right. Next one, C. So C is the integral of f of x plus 2 g of x. Basically, you can simplify this whole thing to be integral negative 1 to 8 f of x plus 2 times the integral negative 1 8 g of x dx. So I'm just essentially, you imagine kind of distributing this to these, and then the 2 can come out front. So I know that negative 1 to 8 is 7. So this is a 7 plus 2 times of g of x is 21. So that's 42 plus the 7. That's 49. So for C, that's 49. Okay. It's literally just one of these integrals plus 2 of these integrals. That's what it is. So it's 1 7 and 2 21s. Okay. Last one, D. So we have a very similar thing. We have g of x, then we have a minus 2. So I know the g of x. Okay, well, g of x is, I know that one is 21. So let's rewrite this as 2 integrals. So I have integral negative 1 to 8 g of x dx minus integral negative 1 to 8 negative 2 dx. So I know that this right here, that's 21. So it's going to be 21 minus the integral. I'm actually doing a double negative right here. I don't want to do that. So this is going to be a regular plus right here in front of the 2. So I already have my minus. I don't want to do a double minus. So minus the integral of negative 1 to 8 2 dx is what this is saying. So if you think about that, that area from negative 1, I mentioned this is negative 1, this is 8, that's 2, right? Well, the area of this rectangle is 2 times that width. That width goes from -1 to 8. This is like a width of 9, so it's 18. So it's 21 minus 18, which is 3 for D. D is 3. Okay, 3. The graph h of x is composited of 3 different line segments, and a semicircle is shown. -4 to 6. Evaluate the following intervals. So, okay. This time we have a graph. This is very common, like AP FRQ. They'll give you a graph like this, and you'll find an interval of some region or a missing region of this. So first one is from -2 to 0. So okay, always get to mark those bounds. We got -2 to 0. It's this bounds. It's this region right here. I'll kind of shape that like this. This is the region I'm looking for. Okay, so what's that area? Well, this is a circle, right? You can imagine like this would be a complete circle. The area of a circle, right, equals pi r squared. But here, it's a fourth of a circle. So the area of this region is a fourth of whatever the area of the full circle is. So the radius of this is 1, 2. So the area of the full circle is pi 2 squared, which is 4 pi. And then divide that by 4 is just pi. So this region right here, this is pi. Or, negative pi, because it's below the x-axis. Okay, now I want the interval from -2 to 6 of -h of x dx. So again, this negative, I can just pull that out front, make things easy for me. So that way I can just focus on the graph and I don't have to worry about converting it. From -2, so same region, but now we're gonna go all the way to 6. So that's negative pi. This is another negative pi, right? Because it's the same as that one. And then I need the area of this triangle, which is a height of, height of 2, and then a base of 1, 2, 3, 4. So that's 2 times 4 is 8. 8 divided by 2 is 4. So this has an area of, this region is 4. It's 2 times 4 over 2, which is 4. Base times height over 2 is 4. So what this comes out to is 4. This is B. It comes out to 4 minus 2 pi. But remember, I'm making the whole thing negative. So I'm just going to distribute. I'll show you how it looks. It's just a negative 4 minus 2 pi, which becomes -4 plus 2 pi. Okay. Next one. Area from 0 to 6 of the absolute value of h of x. So absolute value means make it positive, right? So whatever the value is, it's positive. Okay. So for 0 to 6. So we know that this region is already 4. That's not going to change because it's already positive. But then we have this negative pi from 0 to 2. See how it's negative pi? This absolute value. So what this kind of looks like is absolute value negative pi plus 4, absolute value, which is equals pi plus 4. Okay. This absolute value just means make it positive. So we have negatives in there, we turn them positive. Okay. Last one, negative 2 to 4 h of x dx. Sorry, -2 to -4. Oh, so these are in the wrong order. So this is the same thing as -4 to -2 h of x dx. So -4, that's this region right here, which is a triangle with a height of 1 or a base of 1 and a height of 2. So it's 2 times 1, which is 2 over 2 is 1. So this area of this is -1. So this is going to be equals -1, which is just 1. Okay. Okay, continuing on, backside, write each integral as a question as a single integral. We have 7 to 3 plus here. So good habit to get into is when you see integrals kind of in the wrong order. So yes, it should always be on low to high. So we don't want to convert that. So this is the same as negative integral 3 to 7 f of x dx plus integral 3 to 9 f of x dx. So all I did here was convert. And then if you take the difference of these two, again, like the visual is helpful here. So like you can imagine you got 3 to 9 is like this region. And then you got minus, so you got 3 to 9, it's like the big. And then you subtract the small, 3 to 7. Look, minus 3 to 7. All we have left with is this region here, 7 to 9. So the answer to this one is integral 7 to 9 f of x dx. Okay, it's 7 and 9. Okay, this one, very similar. What this is saying on the right here is that they just go in order. So it's A is less than B is less than C, which is relevant to how this works. But it's very similar. So it's like you have some integral, some value. You have an A, you have a C, and you have a B. And this is saying that A is smaller than B is smaller than C. So if you have A to C, which is the big one, minus B to C, which is the small one, what do you have left? A to B. This is what's left over. So this is just integral A to B f of x dx. Okay. Continuing down. While driving to work, Mr. Matlock's velocity is given by v of t equals 15t plus 10, where t is measured in hours, and v of t is miles per hour. Determine how far Mr. Matlock lives from school if it takes him 1 hour, 4 hours, 1/2 hour, or t hours. So, well, this is pre-antiderivatives, so we can just work at this one at a time. So you have velocity here. This is velocity, and this is time. So let me very clear. This is time. At the bottom, we can start with t, and this is velocity. To find distance, we want the area under the curve at different values. So the first one is at 1 hour, and we can use trapezoid rule to do this. We know this is 10. That's given by the y-intercept here. See, that's 10. So I know this is 10 right here. And then, if we think about trapezoid rule one more time, it's 1/2 b1 plus b2 times h, where this is your b1 and this is your b2 and this is your h. So, okay, well, I know the h is 1 here. I know that the b1 is 10. And I know that the b2 is, well, it's at 1. So I would plug in 1 into my equation. So it's 15 plus 10, which is 25. So this right here is 25. So B2 is 25. So I would just do 1/2 10 plus 25 times 1, which is 35 over 2. Okay. And so it's the same. I'm not going to do it for all of them, but it's the same process of 4.5. Like you would just mark it. And then for t hours, like if it's some t, this is actually what we did kind of in class. It's going to be, you fill in the equation, 1/2. B1 is always 10. B2 is always the height at wherever t is at. So you can kind of think of that as like the v of t. I'll just plug that in for now. And then it's multiplied by t. So t is just however long it took. V of t is the output of that region. So let's say hypothetically I made this t, right? And this is my t that I was using. My B1 is still 10. My height, this distance here, is just the length that t is. So this is just t. And then this right here, this distance right here, this would be my B2 in this case, would be whatever value my function is when I plug in t into it. So essentially this is v of t, or 15t plus 10. if that makes sense. So it's just this height. That's B2. So you get is this. I could simplify this further by plugging in 15t plus 10 into this. So that would become 1/2 20t plus, sorry, just 20 plus 15t times t. This is the annoying thing about t, is that it looks a lot like a plus sign, but you can sort of read what I'm putting here as 20 plus 15t times t. That would be the area for any t hours. Okay. Okay, the rest is review. And so the first one is power rule. You bring the 3 down, subtract 2, you get 18 x minus 2 all squared, right? That's really horrible 18. There's something wrong with the paper there at that point, but that's an 18. This one, I did scratch this out on your paper, but now you can do it. This, we know that the derivative of sine is cosine. This is just 2 cosine x. This one, you have to FOIL it first. So let's see, that's going to be 2x squared minus x plus 10x minus 5 simplifies to 2x squared plus 9x minus 5. Then power rule it. You become 4x plus 9. That'll be that one. The next one, you just divide them all by x. So you take an x out of each one. This is going to become x squared minus 6x plus 2. Then take the derivative. That's going to become 2x minus 6. And that's my answer. Okay. Last one, use the power rule to write an equation first by expanding it, then finding the equation. Okay. All right. So first we got to expand it. So this f of x equals, what is this? X squared plus x minus 12. When you multiply these together, you get this. And then if you remember the equation, y minus y1 equals mx minus x1. This is the equation to know for this one. So I have my x. This is my x1 really, is a 3. I'm going to put that out to the side here. x1 is 3. My y1 is going to be, just when I plug in 3 into this, what do I get? So it's 9 plus 3 is 12, so it's 0. And then my m is just the derivative of this. So derivative is 2x plus 1, but it's specifically at 3. So it's going to be 6 plus 1, which is 7. So m equals 7. Then we'll plug it in. So we have just y, because it's y minus 0, equals 7x minus 3. And that's it. That's the homework.